Hello, this is question 7 on paper 1 of TMUA 2017. So we're given the first 3 terms of both an arithmetic progression and a geometric progression, and we want to find the sum of the first 10 terms of the arithmetic progression. Okay, so first let me remind you of the formula for the sum of the first n terms in an arithmetic progression. And because we're looking for the first 10 terms, our n is going to be equal to 10, and the a is just the first term in the sequence, so that's just going to be p. So you can see that all we're missing is the d, and if we can work that out, then we can work out this sum. And to find d, we can use the formulas for the nth term of arithmetic and geometric progressions, along with what they tell us that the terms are. So because the first term in both of these formulas would just be equal to a, and we know that's p, let's just use the second and third terms. Okay, so first of all, for the arithmetic sequence, u2 is just going to be equal to p plus d by using this formula, and we also know that that's equal to q. And similarly, u3 is p plus 2d using the formula, and that's equal to p squared. And if we now do the same for the geometric progression, the second term is going to be first term multiplied by the common ratio, so the first term is p, and we know that's equal to p squared. And the third term is going to be p times the common ratio squared, and we're told that's equal to q. So now we have 4 simultaneous equations, so let me label them. And hopefully by looking at 3 and dividing both sides by p, it's fairly obvious that the common ratio r is equal to p, and then putting this into 4, we're going to get p cubed on the left hand side, so q is going to be equal to p cubed. So now putting this q into 1, we're going to get 2 simultaneous equations for p and d from 1 and 2, and let me call this I and II. So now if we do II minus I, we're going to get that d is equal to p squared minus p cubed. So now we know what d is in terms of p, we can sub back into one of these to find out what p is. So let's say I sub into I. So by putting this d in for... Okay, so now we know what d is in terms of p, we can substitute into one of these to find out what p is. So say I substitute into I, then rearranging so it's all on one side, we get this cubic in p, and we can see immediately that p factors out. And you can either use the quadratic formula on this quadratic part, or if I rewrite this minus p as minus 2p plus p, you might be able to see that p minus 1 is another factor. So when we bring that factor out, we get that our cubic is equal to p times p minus 2p plus 1, which gives us these 3 roots of p. And we're told in the question that p is negative, therefore we must take p equal to minus a half. So now if we put this p in for d as well, we have this, and when we work this out, we see that d is equal to 3/8. So now if we use our formula, we know now that our p is equal to minus a half, and also our d is equal to 3/8. And plugging these into the formula, this is what we have, and just simplifying, we end up with 5 times 19 over 8, which is the same as 95 over 8, which when we go back to it, we see is answer B.